Alright, so we're going to, if you look at the title of this video, the square root function, you already know the answer to part of the question, determine whether the relation is a function, but let's just pretend like that we didn't see the title. So it says graph the equation and state the domain and range, determine whether the relation is a function. So, looking at this equation, I'm going to go ahead and start off with a table of values. And like the previous video that I showed you, we're going to just pick some values, and I'm going to show you very quickly why the values that I picked in the last video aren't necessarily going to work for this one. If I take and put in a -2 into the x place in this equation, then I'm going to have what we call an imaginary line. Imaginary number. So putting a negative into this thing is not going to work. -2, -1, nothing. So immediately I see that this is different than the last one, in that I can't just put any x value that I want. Let's see if 0 is going to work. If I put in a 0, then I can actually take the square root of 0, which is 0. So actually a 0 is going to be fine to use. What about a +1? Well, square root of 1 is 1, so that's fine. Now, here's what I'm going to do. I'm going to change the 2 to a number that really does work well with square root. In other words, I have a right to decide what numbers I'm going to choose for x as long as they work. Well, I want them to work really well, so I'm going to choose 4. Because 4 works really well. And so I'm going to say, okay, 4 goes in there, that's going to give me then a 2. And then I'm probably going to give myself one more. Let's do putting in a 9. Okay, let's continue this. Let's give ourselves a 9, and when we put in a 9, we're going to get a 3. Now, so immediately you see that sometimes we have to manipulate the x input. In other words, we decide what we want that would help us. All right, so we definitely want to manipulate when it comes to math, right? Not anything else, but definitely math. Here we go. I'm going to put in my points. Over 0, up 0. Over 1, up 1. Over 4, though, I'm going to go up 2. And over 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. I didn't get quite large enough on my grid paper, but that's okay. So this is really a curved piece. This is a curved graph. All right. So I'm looking at the graph, and it would definitely go on and on and on. Here's why we couldn't put a negative in. You see this right here? There is no graph there. The reason that negatives wouldn't work is because there isn't a graph, and that's what we're talking about. When we're talking about the domain, we're saying, hey, what x values would really create part of the graph? And so when I'm talking about stating the domain, let's just take a look at transitioning from the picture to just the table. I could think about turning on the x-axis as a magnet, and my domain is definitely 0 to infinity. So let me go ahead and include 0, pardon me. In interval notation, we would include 0 this way, 0 to infinity. But let's just look at the table and see if we can come up with it from the table. I'm not allowed to use negatives for my input, which is the domain, right? Can I use 0? 0 worked. Positive numbers are going to work. Even positive numbers like putting in a 2, right? That would have worked, but that would have given me some kind of decimal, and I just didn't want to deal with decimals. So positive numbers are going to work even if they're not perfect squares. So anyway, my domain is quite clearly 0 to infinity. So let's take a look at the range. Now, the range would be 0 to infinity if we think about the magnet turning on for the y-axis and all that red stuff going as quickly as it can to the magnet. We would see that it's 0 to infinity. But let's take a look at the output over here. So far, is it possible that we could have had an output of negative? Well, no, because it's asking, this is the principal root right here. There's no plus or minus, right? There's no plus or minus. If there's no plus or minus, then they're only wanting us to give them one answer. If I put in a 9, I don't get plus or minus 3, I just get 3. So I'm not getting a negative. The only thing that I'm allowed to have as an output, that's showing up as an output, is from 0 to infinity. And that's what this is confirming right here in the table. It also is confirmed here when I think about turning on the y-axis as a strong magnet, we would get red stuff all through here. Okay, I hope that helps you in transitioning from a visual domain and range to just using a table. And by the way, we do know that this indeed is a function. Thanks for watching.